So good morning, everyone. How are you this fine and wonderful day? You're excited to learn about Insight? Hopefully you're here for Insight. Spreadsheets? That's all we're going to talk about. I might mention EasyBuilder just a little bit, but that's just so you see where EasyBuilder gets its information, because spreadsheets where it's at. So a little bit about Cognex. We're a publicly traded company, founded in 1981. 2 of the 3 founding members are still with the organization. Okay, Dr. Bob is still there. He's our Chief Culture Officer now, but he's still chairman of the board. What we want to do is we want to improve your product quality, eliminate your production errors, lower your manufacturing costs, and exceed your expectation. Products at an affordable price. I know we're not cheap, but I think for what we offer, we're very affordable for what this little unit can do. I think back to the days when I first started there, and they had this big pizza-sized box type units that were OF1s that would go for $40,000, $50,000 just for that board in there, and they barely did OCR, which now, that's like almost nothing for us, what they're doing. So it's just amazing how things have changed over the years. We can service an international customer base because we do have offices located in China, in Europe, in Japan, in Latin America, all the different places we have them, as well as our global network of integration and distribution part. So Cognex offering, we are a machine vision company, so we just focus on machine vision. But we got a lot of different machine visions we do. We do things from DataMan, which is just a 1D and 2D barcode reading. Okay, it could be handheld or fixed mount. We do Smart View, which Smart View is your surface inspection. So these are like non-woven materials, your glass, your plastics, your metals, your papers and stuff. What they're looking for there is, do I have some type of bug that got stuck in there? Do I have some type of imperfection? And it's kind of a way that they can rate, the quality of papers coming out that's being used. We also have Vision Pro. Vision Pro is our vision software. It runs on the power of the PC. So it uses the libraries, our tool libraries and everything, but it uses the multi-core processors and the speed of the CPU to run the program. It also has a very large variety of cameras that it can use, because we're using third-party camera sources, whether they be Gigi, I'm trying to think, Firewire, CameraLink, all different types of cameras. Then you have Insight, and Insight falls underneath the vision system, because the camera and the processor and everything's all in one. So all your I/O, all the actual programming of the unit, the acquisition, everything, is all being done on the camera itself. Okay, so that's kind of its own little unique subsystem there. We have Checker. Checker is kind of a smart sensor. Presence, absence, is something there, is something not there. It can also do some limited measurements, but once again, the measurements are always relative. They can't tell you that's 22 millimeters, but what they can tell you is it within this level that you stated? Now, if you change your focusing or where your camera's placed, then all bets are off with that one. And then finally, just coming out this year, is the displacement sensor. And the displacement sensors are, let's say our first commercial foray into 3D systems. Okay, so it's actually a laser line system that picks up the 3D. We get a range image from it. We get a 3D part coming from it. Currently, that's being supported through our Cognex Designer software, which right now uses Vision Pro. So we have a whole big host of vision products. Now, since we're teaching Insight, you would think we should concentrate on the Insight ones, correct? So that's what we're going to talk about. We're going to talk about the 7000 series, the Micro series, and the 5000. We're also going to talk about the Vision View and how Vision View can be used. Now, Vision View needs to be done in a production environment. Your development environment is still going to be using your PCs, but Vision View is going to show you it in production. It's going to show you any custom views that you created, as well as image and graphics that's coming from the system. So that's kind of nice. Gives you an easy way to get to it. And then we're also, of course, we have to cover the Explorer. Now, what we're going to find is as of Explorer 4.1, it supports both EasyBuilder and spreadsheets. But we're going to stay in spreadsheet, because that's what we care about. That's where the power is at, is in the spreadsheet. Now, because we're a machine vision company, we really focus on machine vision, and we try to avoid doing accessories when at all possible. So what I mean by that is there's not many lighting things that Cognex makes. You might be able to find 1 or 2 that we might have designed, but instead we try to team up with world-class vendors, such as CCS America, Advanced Illumination, Smart Vision, for them to have lights. Very often with machine vision, it uses LED lights. Now, we'll go over a whole lighting and optics section either by the end of the day tomorrow or first thing on Thursday, whenever that falls into place. Lenses, same type thing. Don't make our own lenses. Instead, we offer Fujinon, Cosmic Art, Edmund Optics. We try to get you good quality lenses to make sure that you're not going to distort that image coming up into the camera, because what we find is garbage in, garbage out. If you're not getting a good picture, how can you analyze a good picture? As far as cables, of course we do cables. The cables are made by Molex. That's to give us that nice secure connection to it that can get us up to an IP67 rating if the lens caps are put on, which basically means that if your cables are connected and the lens cap's on, you could actually stick it in a fish tank. And then the I/O modules, we make our own. That we actually do make because they're not passive. There's actually a little microprocessor on board that's going to give you additional inputs and outputs for it, as well as accessibility to serial if you're using it. And then finally, Vision View. Vision View and the operator interface, we all designed that ourselves as well. We have different versions of it. Some are just software only. Others are hardware and software, and we'll talk about that in a bit. Now, all the units are Ethernet, okay? So in order when you connect up to it and everything, at a minimum, you're probably going to at least be setting what your IP address is and giving it a job. Even if it's just, hey, I'm replacing it or something, you're still going to have to, at some point, get Ethernet connectivity to it to put this stuff on. Now, it doesn't have to run with it. As soon as you have it all set up, you've got the job running. It doesn't have to be on Ethernet unless you're using Ethernet to control it. Otherwise, you could pull it off and off it runs. It can tell its I/O module, kick it off, save it, whatever they want to do. Okay? Now, in my tech support, what had happened was a lot of customers would say, hey, do you work with system XYZ? And though I was really good at my job, there was no way I could remember what every single system out there, how it communicated. So one of the first things I would ask the customers, well, how does system XYZ communicate? As long as it uses one of the protocols that we support, it should be no problem. Whether it be TCP/IP, FTP, Modbus, EIP, however you want to communicate, as long as it's one of the Ethernet protocols we support, and they're not asking for some type of proprietary control type characters, we should be good. We should be able to communicate with them. So, okay, and we have a very large range of different protocols we support. We've also made communicating with PLC very easy. First, people thought that it was mostly Easy Builder that we made it easy, because you just set up and point to what you wanted. But they also made it easy in spreadsheets. Because before, for anyone who's done PLC programming, and how many of you guys had to do PLC programming? Yep. You guys know about map specs, right? And it used to be inside the software, you'd have to write that map spec. And so people who knew PLCs really well, they could do it, and they weren't as concerned with it. But the new PLC programmers, what's that map spec? What are you guys coming up with? That's not our spec. That's the PLC spec. Okay, so how they got around it is now they have this buffer. And what you basically do is you point to what values you want or what values you're expecting to get back, and it goes through the buffer, so it creates that map spec for you. You're never doing like :F and everything like that. It's just all done for you. Okay, and you just say how big of a number you want, and then it takes it from there. We can support Ethernet IP, DeviceNet, CC-Link, MC Protocol, and Profinet tends to be the communications we do with PLCs. We also do robotic communications. Now with robotic communications, it's usually a third-party controller, the robot, who wants to control Insight. And so in order for a third-party device to control Insight, very often you're going to use native mode commands. Now these native mode commands can either be serial or Ethernet. Now which one do you think most people are using with robots nowadays? Ethernet's going to be far faster than serial. Now there's still some serial robots out there and everything, because if it's not broke, let's not fix it. Just leave it there. But a lot of them are now going towards Ethernet. Now both of them can communicate in this idea called native mode. And native mode is just a special set of commands that when the Insight sees it, it knows to do special events, such as if I send an SO0, it knows to go offline. If I send an SE8, it knows to do a manual acquisition. So beautiful, has all these commands. So it allows the robot to switch information back and forth with it. But we also have things like PatMax. And we're going to just brush on PatMax today, but we're going to go into it even more Thursday morning. We're going to actually play with that tool and see what's really going on with it. So it's a great pattern finding tool that's very repeatable, and it's very accurate where it is. So with robots, that's what they want. They want accuracy because you want to get right down on top of it. So PatMax is wonderful with it. We also have nonlinear calibration. There might be a situation that your camera can't be right over your part, like maybe how the robot's coming over, it can't quite get there. So your part's going to look kind of skewed in the field of view. But we can still calibrate with that. As long as it's always going to be that view, I can calibrate with that view and it knows how to accept that. So we can deal with nonlinear calibration. Robot drivers and sample code, we have some of the major robot white papers up on the web. I want to say like ABB's up there. I want to say FNUC's up there in KUKA. So quite a few of the white papers have gone out with people who have tried saying, how do I establish that communication? How do I get it going? No problem, we have that available for you. And then of course, the vision tools. Because the robot, the whole idea behind it, the robot's probably going to function depending on what results are coming back with these vision tools. So finally, we want to eliminate costly precision because we're going to find that we can fixture in the actual vision world as opposed to having to have mechanical fixtures. We can also process various part types without tool changeovers. We're going to talk about how to make a job able to accommodate multiple type parts coming into it. And finally, unless you're playing extreme robot games, your managers probably don't really think it's very funny if robots are colliding into each other. I mean, that's great for maybe a YouTube moment, but otherwise management kind of frowns upon that. Now we have the EasyBuilder user interface. And now if a program starts in EasyBuilder, you can go to spreadsheets, change some things, and go back to EasyBuilder. But if a program starts in spreadsheet, it stays in spreadsheet. So basically, EasyBuilder, and we're going to find out this idea of snippets in a bit, EasyBuilder is just a set of snippets that allow for this like GUI type interface that lays on top of the spreadsheet. The truth is the spreadsheet's still controlling it. It's not like it's a different type thing. It's a different environment to program it in. Same code behind the scenes. So it's great for intuitive steps for your application. You don't need to know anything about programming. And you can actually play with some of the vision tools. But spreadsheet's where the power's at. Spreadsheets is where you can get into your full control of your vision application. You can create custom graphics and everything. We used to say that you could get to complex logic. Now you can still do complex logic in EasyBuilder, but it's one of those chicken or the egg thing. Because you need to understand how logic is programmed in spreadsheets to be able to write it into EasyBuilder. Because that's all that you're doing is you're just adding a little bit of code into there. But the code is being written in spreadsheets. So if you understand it in spreadsheets, then it's no problem to put it into EasyBuilder. So like I said, if you start in EasyBuilder, you can go back to spreadsheets, make some changes as long as you don't break the EasyBuilder environment. It can go back to the EasyBuilder. Beautiful. But if you start in spreadsheets, you stay in spreadsheets. That's because the setup's not set up for EasyBuilder anymore. It's right down into the spreadsheets environment. But that's where all your control is going to be, right inside the spreadsheet. So let's talk a little bit about the hardware. So we have the 7000 system. Okay, so we have everything in one little package. The 7000's claim to fame is two things. One is that it has some integrated lights. Okay, so we have these removable lights that goes right around the lens of the camera and everything, and they can be like red, blue, white, IR, different options that they create. And it's field replaceable. Oh wow, this looks really good with white light, but this part looks better with blue. Put it in. Oh, yeah, there we go. No problem. Not like you have to send them back to us. Now you could say, well, the 5000 has those integrated lights too. Yes, it does. It just doesn't offer it as many colors. Now the other claim to fame for the 7000 is that it has a autofocusing lens that you can buy with it. Now it can be C-mount, so you can put a normal C-mount lens on it, but otherwise you can do this autofocusing lens. Now how many people have heard of liquid lensing? No one's heard of liquid lensing? A little bit? It's got a lens with two liquids on it. And basically the amount of current that you put through it starts making either convex or concave, so that's changing your focus. So it allows for you to focus dynamically on the part. And like you said, yeah, I wouldn't be shocked if a lot of the phones have it. Some of our other devices have it. Now the problem with liquid lensing, if all of a sudden it's a very stormy day, your focus metric is going to be very different than if it's a beautiful, bright, sunny day. Because we're talking liquids and we're talking pressure. So as pressure changes, so doesn't volume and how things look like for liquids. So what Insight's done is we have a mechanical auto-adjusting lens. So it has, I want to say 255 steps that it goes through to adjust. But what that means is that when I turn it back to a particular step, when it goes back to it, it's going to be that exact same step every single time. I don't have to worry about that, did the temperature change or did the pressure change or something like that. It's going to be the exact same level every single time. Now one thing I should note with this, it is a mechanical lens. So this should not be adjusting with every single acquisition. If you're adjusting it with every single acquisition, you're going to start doing wear and tear on the parts, heating up, and everything like that. But very often it's going to be like part changeover. Oh, got another part coming in. Okay, now we're ready to go. Boom, 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 boom. You know, so a lot of people think, oh, I can adjust on the fly. You could. You're just going to be beating on this poor lens a little bit more, not to mention it's still going to be a time for that adjustment. And very often when we're talking machine vision, we're talking things in the microsecond range, the millisecond range, not inside the second range. Second, our micro, smallest system, 30 by 30 by 60. A lot of people like that because you can actually put it on like a robot arm, not very heavy and everything. It is PoE. So what's PoE? Power over Ethernet. And what does that give you? Less cables, one less cable, you don't have to power it. As long as you have a PoE switch or a PoE injector, you're good to go. Your Ethernet comes in, your power comes in, and then it all goes up that same Ethernet cable that the others use. So like I said, nice little small unit. Doesn't have integrated lighting or anything, but you can very easily use external lights to control it. What we're going to find is after you get past the acquisition of the image, the program's all the same. It doesn't matter what system you're using. Programming is going to be the exact same. It's going to be getting the actual image itself that may change between it. Otherwise, has all the I/O connections from its M8 connector in the back, and it offers all the Ethernet protocols, just the 5000. And then we have our 5000. It's the one that's going to have your highest levels of performance. Okay, this is the one that gets up to, and we'll talk a little bit about it in a moment, 5600. So the fastest processing. It's also going to have your largest image. It gets up to the 5 megapixel range. It can do integrated lights, but they kind of only offer white or red or low angle light. That's about it. And they also offer it in a stainless steel version just in case you need IP68 rating instead of just 7. So it's that washdown environment so that the paint won't start coming off the unit itself. We also offer a line scan. Now the line scan is a 1K line scan, okay, and it can go up to 8K to create your image. So this is where I'm talking about sometimes the difference between the images themselves, getting the image into the system. As soon as you get the image, it's going to look like an area scan image, and you can put your tools on it. But it's getting that image in. And what you're going to be doing is you're going to be taking a strip at a time and combining them together. Now think of it like a strip in a crack in a door. If you're looking at that door and no one's moving in that room, you don't see anything. But if all of a sudden someone moves by it, your mind's picking up, oh, there's someone moving by it. Okay, I kind of see what that image is. I saw someone move there. And that's what this does, the line scan. You move by it, it goes strip, 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 gives you that full image. So if you kind of went too fast, it's going to look stretched. If you kind of go too slow, then it's going to look pushed together. But basically, you're getting that image with an encoder, or you can even go encoderless. That's when you have to really control your speed. Beautiful, you got your image. Looks like an area scan. Start putting your tools on it. Now, one of its advantages is that it's great for retrofitting systems. What do I mean by that? Well, let's say you're looking at this system. They want to add vision to it. And they said, if you want to build a vision table that's going to come out to here, it's going to be, let's just say, $10,000 extra and stuff. Do we really want to do this? Well, if you've got a little crack in there, you can actually put the vision there, because if it's moving by it, as it moves by it, it's going to accumulate what the image is, run your processing on it, and then let the system know whether it's good or bad. So with just having just a little sliver inside the line, you can add vision using a line scan camera instead of needing the full area that an area scan camera will require. Now, resolution. I've been talking about resolution. What is resolution? Pixels. That you've got this field of view. So that's what the camera can take. And it's how much am I dividing things into it. So if I have a 640 by 840 image and I still have that same field of view, I'm going to divide 640 by 480. And so a pixel, and this is the picture element, we'll talk a little bit more about that in the next section, can only have a single color. So if I'm dividing it into bigger chunks, it's going to get a little bit, how should I say, fuzzier. So when I'm taking a look at this, I can't quite get the contrast that I'm looking for. I know something's there, but it's just in that field of view, it's just not dividing enough for me to take a look at it. It's a smaller image. I've got fewer pixels, but it's not giving me that contrast, that distinguishing characteristics. Now if I go up to a 1600 by 1200, notice I can read it a little bit better. I can actually read that this says Cognex Corporation, have some information right here. It's a bigger image, but now I've taken that same field of view, but I divided it into more pixels now. And then finally, if I go to our 5 megapixel camera, I can probably get all the way down to the kanji characters down here and be able to read them. Much bigger image, but I can see things much better. I've got better contrast there. So we can offer them in all different types of resolutions and speeds and everything, depending on your requirement. A lot of times what's driving this is very often money. I want a lower cost, but I want, kind of what I want. So we don't offer every single combination, but we do offer kind of the general ones. We're going to say that these are only new units being sold now. If someone were to show me the camera, I bet you I could tell the difference between the camera. Don't you think so? If someone showed you a 7,000 versus a micro and a 5,000, you'd probably very quickly be able to say what the difference is. But what if your boss came up, gave you a sheet of paper, and said, this is what I'm about to order? So now you're looking at the paper and you're trying to decide, is this going to work for us? Is that max? So the very first digit there is going to tell you what family it is. So if it's a 1, it's going to be a micro. If it's a 5, it's going to be a 5,000. If it's 7, it's going to be a 7,000. Now your second digit is going to be your processing speed. And your processing speed is going to affect the processing of the vision tools. Not the acquisition, but the processing of the vision tools. So the processing of the vision tools is just one component of the 3 times that go into your cycle time. So you got your acquisition time, your processing time, and your exposure time. So we're talking the processing there. Now, I need to pick some type of base. If I were to tell you that it did, 17 swaps per second, that would mean nothing to you. So what we have to do is we have to take a unit and we have to say, this is our base. This is our reference point. Micro 1020 is going to be our base point. It's our kind of our bare bones, slowest system that we have. And we're going to say, okay, however long it takes us to do vision tools on this, that's what we're going to say is our reference point. Now, if I go up to a 1, so this might be an 1100, a 5100. So now what that means is I am going to be running 4 times as fast as my 1020 did. If I go up to a 2, and this is only available in the 7000s, I'm now going 6 times as fast. If I go up to a 4, this could be a 1400, 5400, 7400. Now I'm going 12 times the base. And now the 6, which is only available in the 5000 series, because remember I said the 5000 had the fastest processor. That's the 5600. And the 5600 is going 20 times the base speed. So you can decide how much processing speed do you need for your application. Now your third digit is going to tell you whether it's ID only. And so this was for some people who wanted, I don't want to buy the whole Insight unit, I just want ID. Can't you give me a break here? So they said, okay, we'll give you a break. We'll give you 1D and 2D barcode reading as well as optical character recognition, optical character verification. So the ability to read human readable font. You don't get any histograms, no blobs, no pattern finding tool, no edges, nothing, just those basic tools. If I have a 3 there, it means some people just wanted OCR, optical character recognition. And this is because we put out back in, I want to say 2 years ago, we put out OCR Max, where we basically took our OCR tool and revamped it. Made it so much easier to use, made it better to deal with changing environments, changing fonts that are going into it, the different types of way that fonts are being printed nowadays, like dot matrix font. All that taken into place, we came out with OCR Max that deals with that. So some customers said, hey, I just wanted an OCR reader. That's all I want. Now when we go to the 4th position, that's our resolution. So that's what's going to be that acquisition time. That's where that's coming from. And that's saying how much the imager, how many resolution that imager is being divided into. If it's a 0, and you're using anything but the 7000, it's going to be a 640 by 480 image running at 60 frames per second. So that means a full framed image takes 16.6 milliseconds to acquire. If you're dealing with a 7000 though, you're actually getting an 800 by 600 running at 102 frames per second. Now you might say, well, honey, where does that difference come from? That difference comes from the fact that the micros and the 5000s use CCD technology, charge coupled devices, while the 7000 uses a CMOS. So CMOS has actually gotten up to be to the level that the quality of the pictures rivals that of a CCD. So that's why we're starting to use CMOS, but they're faster. So this would be called what's called DGA mode. That's that 102 frames per second at 800 by 600. That's VGA mode. Now if I go to a 1, I now move up to 1024 by 768. Notice I'm at 20 frames per second now. So it's slowing down a little bit because I've got more pixels I've got to bring in. Now if I go to a 2, and that's only available in the 7000 series, I'm now dealing with 1280 by 1024 and running at 60 frames per second. This is SVGA mode. Then if I go to a 3, I'm 1600 by 1200. Once again, slowing down even more, 15 frames per second. If I'm at 4, it's our line scan. Okay, in our line scan, it's 45K lines per second, but basically we said if you had a 1K by 8K image, I think we worked it out to be 7.7 frames per second for it to acquire, so slowing down a little bit more, but lots of pixels in there. And then finally, our 5 megapixel camera, which is 2448 by 2048, which is only 16 frames per second. So that means it takes 60 milliseconds to acquire that image. But you're getting all those pixels into it. Sometimes having that larger image come in can negate the need for acquiring 2 other images because of trying to get to the little small details. Instead, one big image cut down to some small resolution, and you can find what you want. Then it goes dash, and then you have a number there. If there's a 0 there, it means it does not have PatMax. If there's a 1 there, it means it does have PatMax. PatMax is the only tool that's a payable option. If you buy it at the time that you buy the unit, I think it's about $500. If you buy it after the fact, it's $1,000. And then finally, everyone's dealt with flash drives now, right? Your little USB drives and everything. And I don't know if you guys know this, technology changes quickly. It's the flash drives. Flash has changed over there. Well, first, one thing you should know is flash is actually finite. You can record to flash till at some point you can't record to flash anymore. So it is finite. But it would take, I think they said, saving and loading every single moment for 7 years will finally make the flash die in these things. But we had to change how flash are dealt with. So because of that, this is a designation that we kind of let our hardware know that it's the newer flash that we're using in the cameras instead of the older ones. Just makes it easy. Now, unfortunately, it's not just like one broad stroke and, hey, this is how it always works. Unfortunately, really, 5000 behaves one way with it. The micro behaves another way with it. So kind of all bets are off. But it's a way for you to know that you have the newer flash on there. So we have a nice little table with all the different parameters that you might need. So if there's one particular parameter that means more to you, you can see what family owns it. Or if there's one family that you're using, you can see how it ranks up against all the parameters. Then we have the I/O expansion modules. Now there's certain I/O that's already on the cameras. If I'm using a micro or a 5000, I have one input, not truly an input. It's a camera trigger. Okay, so it's an optically isolated input that when current flows through it, it's going to cause the camera to acquire. And then it has 2 outputs. It also has 2 LEDs. The 5000 actually has serial on board. It only has TXT and RXT plus ground. Well, here's the key with that. If you're doing serial communication and it's looking for hardware handshaking, you got to go to an I/O module. Otherwise, if it just needs TXT, RXT, and a ground, you can connect right up to the camera. Now, the 7000 is a little bit different. The 7000 has its trigger, camera trigger, but I believe it has 2 other input triggers. They also give you 3 outputs for it. So instead of just the 2 that the 5000 and micro has, it actually gives you 3 outputs. In fact, I think as of 4.9, it gave you 4 outputs. And it also has LEDs on it too. If you take a look at the front up here, there's going to be 2 user definable LEDs that you're going to be able. One's going to be red, one's going to be green. Now, if you're using a 5000 and you need additional, like you actually need inputs, or you need additional outputs, you can use the CIO 1400. So what that's going to do is going to give you 7 additional inputs as well as 6 additional outputs. It's going to give you RTS and CTS, which gives you serial hardware handshaking. And then it's also going to separate your input and output commons. Now, what's a benefit of having separate input and output commons? It allows for your inputs, because your inputs you might be communicating with an NPN device, but your outputs might be going to a PNP device. So it allows for them to have separate input versus output. Now, within your inputs, they're all going to be tied to the same ground. And within your outputs, they're all going to be tied to the same. But at least your input and output can be separate. If you're using a micro, a 7000, or a line scan, you would use the CIO micro. It actually gives you serial port. If you're using the 7000, I believe once again it brings it out that you have the full RS-232 communication. It's going to give you 8 inputs 8 additional outputs. Once again, you're going to have separate commons. And it's also going to act as a PoE injector, because you're going to have your Ethernet card, your Ethernet line coming in, and then the line coming right up to the camera, which is going to be PoE. Now, we're using a 7000. Is that PoE? No, but we're going to be connected to the camera. Is that going to be an issue? No, that's how PoE works. If it's connected to a non-PoE device, power's not put on that line. So it just becomes just an Ethernet connection to it. Otherwise, if I connected a micro to it, I'd be able to power it and talk to it at the same time. Now, if you're using the Mitsubishi PLCs, we also offer the CIO Micro and CC Link as well, which just basically puts you a couple of registries on it. So it's just a hardware registry on the board itself. So we have a little table in there. Depending on what I/O board you're using, it shows you what your different settings for lines and stuff would be. Or if you need a certain amount of inputs or outputs, you can see, well, am I going to need an I/O board, or can I just stay with the camera? Then we have the Vision View Operator Interface Panel. So like I said, this is to be used for production, not as opposed to development and everything. So for the production, this is what you're going to see when you're at runtime. If you have any custom user interfaces, people have access to that. If you just want to see the image and graphics going on, beautiful, you have access to that. You can see up to 9 systems at a given time. When you're using custom user interfaces, you can only see that when you're on that individual picture. You'll see the user interface. Otherwise, you'll just see image and graphics if you're tiling up to 9 of them. We'll go more into that in the deployment section. I think that's the one. So before we get the lab, one more thing we got to do. Because the first part of the lab is going to be connecting up the unit. The second part of it is going to be actually connecting to it, so that we know that's our unit, that's our camera, what can we do with it. So usually, how you would connect to your camera is you would open up the software, switch it over to your spreadsheet viewing settings, or have your software automatically start up a spreadsheet. Then you're going to see over to your left-hand side, there should be a network bar. And it might show the different cameras that are sitting there. So if you know the name of your cameras, all you have to do is double-click on it, and you'll connect to that camera. What you'll end up seeing is anytime that you connect to one of the cameras, you'll see a little grid behind it. Do you know where these little PCs are coming from? That's your laptop running Insight Explorer. So it's acting as the emulator, so you'll see that too. So if you're connected to your emulator, you'll also see a little grid on the screen of that too, so you can see which units you're connected to. Okay, so if you just double-click, you'll connect to it. Beautiful. If only it was that simple. So you're sitting there, typing away, and all of a sudden your screen goes blank. Boom. What just happened? Somebody bumped you off. In fact, they probably double-clicked on your camera. It told them that your PC was currently connected to it, and do you want to proceed? You know what they said? Little jerk said, yeah. So now you can double-click. It'll tell you that they're connected onto it. Do you want to proceed? And you guys can go back and forth jockeying for the camera. Or you can actually turn on your settings, and I'll show you later this. I don't like to do it in the first part, because when we're dealing with spreadsheets, you can be connected to more than one unit at a given time. So you end up locking out the person whose camera it really is. So, but I can go in there in my options, and I can say lock my connections, which basically says if I'm logged onto the system, no one else can log onto it until I release it. As soon as I release it, then other people can log onto it. But don't go to lunch with it. Is when you go off to lunch and everything, if someone's trying to get to that camera, they're not going to be able to. So you want to make sure you release it if you're not using the connection. This is what's going to happen inside our class. We have all these units that were used at the other class that have no idea what their settings are. So we're going to connect up to them, and you're going to see a whole bunch in the list, but you're not going to know which one's yours. What you need to do is we need to find out which one's ours. So what we want to do is we want to go to System, Add Sensor Device Network, and what it's going to do is it's going to pop up this utility box. Now when it first comes up, it's going to look for any units that were set at DHCP. Now what does DHCP stand for? Dynamic Host Control Protocol is what it stands for. So what it does is if you have a DHCP server sitting on the network, it sees the unit, it says, oh, you need an IP address. Let me assign you one. And it gives it an IP address. So the DHCP server is controlling it. But in a lot of environments, you probably don't want to use that. You probably want to put a static IP address in. Now, when it first comes up, when we ship the units, we're going to ship them as DHCP. Very first time that you have the unit, you're going to want to connect onto it and then assign it an IP address. So when you do that, when this utility first comes up, it looks for any units that were set for DHCP, because you're going to get this 169.254.0 and some number come up. And what you're looking for is anyone that's not on the same subnet as you. Now, I am an idiot at times. And when I start putting things in, like the Microsoft's default IP address is 192.168.0 and some number. Well, when I start getting giddy and late Friday afternoon and everything, I put in 198.162.0 and some number, because I'm starting to get dyslexic there and changing things around. So all of a sudden, I'll see it come up on this list, and I'm like, oh, that would be why I didn't see the camera, because I'm an idiot. I got to go in there and change it. So it's looking for any cameras that's not on the same subnet, and it's looking for any cameras that's not DHCP. Now, if your camera was acknowledged, was already on the list, it's not going to show up here yet, okay, because it's only looking for cameras that have not resolved yet. Now, you can go in there, change the name, set it to be DHCP, or set it to be a static IP address. You want to make sure you give it an IP address and a subnet mask. Those are the two main things. If you're on a managed network, then you would put in what the default gateway DNS server, which stands for domain name server, as well as what the domain name is. If you're using a PC on the same network, has the same settings, you can all of a sudden copy the PC settings over, so it brings those DNS settings and all that over. If you're not using a maintained network, who cares? Nothing needs to be there. Just need an IP address and subnet mask. Then we also have this reset to factory defaults. What it's going to do is it's going to get rid of any I/O in the camera, any user list in the camera, but it does not get rid of jobs. It just resets back to a factory setting, but your jobs are still there. Just your I/O and your user settings and stuff goes away. Like I said, it shows the list of cameras that haven't been resolved yet. But what if your camera's already on the list? You just don't know which one's yours. So what you can do is, while the utility's open, right-click and say Show All Devices. Then what it's going to do is show you all the devices that's already resolved, and now you can take a look at it and take a look at your MAC ID address, find out which one's yours, and then by all means change the name. I wouldn't change the IP addresses at this point because if they're already working, that's good. But if you want to try them out, what happens is if you put an IP address of someone who already has the same IP address, you're going to see a little exclamation point next to it that lets you know, whoa, 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 someone's already on the network with that IP address. Common questions. What if my camera's not seen on the list? Number one answer, make sure it's powered on. Amazing. If you don't have power to it, it just doesn't communicate very well. And then what you want to do is especially if it's an older version of software, that's before 4.1, because it was in 4.1 that we actually started using this utility. What you might need to do is, while your utility for Add Sensor is up, power cycle the camera. It might take about 2 or 3 minutes for it to come up, but all of a sudden you should see it come up on the list. I say this because very often what might happen is, if you have the same IP address as another camera on the system, whichever one grabs that IP address first is the one that shows up on the list. The other one's sitting out there in la-la land. So all of a sudden when you power cycle the camera, you see that camera come up, then you see the exclamation point next to it saying, hey, it's got the same IP address as someone else, and you're like, that would explain why I was having troubles with it. What are the cameras shipped as? DHCP. Let's say your laptop's set to DHCP, but it's not connected to the network. What's going to happen? Well, what Insight does is it treats it as a DHCP without a DHCP server out there. So it's going to do this link local addressing. And so you're going to get the IP address of the PC is going to look like 169.254.0 and some number. So it's going to assign it this kind of bogus IP address just so that it can communicate at that point. So what basically they're saying is that not all bets are off if your laptop's set to DHCP, but it's not looking. And also, if it's pre 4.1, and so you can't see it on the list, what do? Same thing as the first one. Power cycle it while the list is open. We talked a bit about the Insights coming in a variety of models to accommodate your resolution as well as your speed requirements. We also talked a little bit about having additional inputs and outputs as well as serial, depending on what I/O module you're using. And we've tried to make connecting to the camera much easier with the Add Sensor utility. So now what I'm going to do is I'm going to go into the first lab. So at the end of each section is going to be your lab. So let's start this first one. It's actually got 2 parts to this lab. The first part of this lab is actually setting up the system, the hardware, and the second one is connecting onto your camera. Now, first thing I should say with this is when you connect onto your camera, don't worry about the image. Don't worry about the image we're taking care of in this next section. So just the fact that we're connected up to the camera, that's where we want to get to at the end of today, or at the end of this section. So now you have a few things in front of you. You're going to have an I/O board, You're going to have a camera. You're going to have a tripod. You should also have a bundle of cables that within the cable bundle, there should be a black power cable. That black power cable is going to go from the back of your camera to the I/O board. You're going to have a green, or rather a teal. So this green cable is going to connect from the camera down to the I/O box. And then this black cable, what I want to do is go from the I/O box to your switch. So everyone on this side of the room, we're going to use the switch right next to you. Everyone on this side of the room, you guys would use the switch right there. Now you'll notice when you're attaching to the back of the camera, one's female and one's male. That's great. That'll prevent you from ever getting the cables mixed up. We're good. And it is keyed. So then the final thing that I want to do here is I actually want to, well, before I do it, I just realized I just got this PC not too long ago. So I don't think everything has been set up correctly on it. So let me say Open Sharing Center, and I want to take a look at my adapter settings. And I've got my local area connection. Yours should all be set up correctly. This is just because this is the first time I'm using my PC. My adapter settings are probably set up for protocol version 4 to be DHCP. That's not going to help me here. So what I need to do is I need to put it on the same IP, the subnet, as this one is. So it's probably 192.168.0. And then let me come up with some number from 0 to 255. 71. Sounds good? I like it. 71. Click on it. Since it knows that it's the default Microsoft, it puts it there. Beautiful. Let me go ahead and say OK right now. Say close. Close. So hopefully, if I open up my Insight, 491, 192.168.0 and some number from 0 to 255. What mine comes up as is it comes up looking like this, okay? Now, this is because I've just installed Insight on it. It's installed in Easy Builder mode. Now, what I want to do is I want to switch over to Spreadsheet. So to switch over to Spreadsheet, what I need to do is I need to say View, Spreadsheet, and it will switch me over to my Spreadsheet mode. Now, let me point out a few things up here. Do you see how it says Insight Explorer, right? And then what does it say right after Insight Explorer? It says admin. That's what I'm loaded on as. Okay, so that's what you're connected to your unit as right now is admin. Beautiful. Then it says what? Train 7, so that should be the name of your PC. Mine says Dusty because that's the name of my PC. Okay? And then right now it's saying standard. Yours may say a color or something. Standard just means I have a 640 by 480 image that can come into it. That's all. I can emulate anything. So I'll show you guys later how to do emulation. And then it tells me spreadsheet view. Beautiful. Now what I want to see is I want to see my network over here, but right now I'm not seeing it. That's because by default, what happens is if I go to Insight Network, it doesn't come up automatically. The toolbars doesn't set the Explorer one. So as soon as I turn it on, I can see my little network things here. So I can turn on Insight Network and I can see what's sitting over here. So right now I see Dusty, Train 6, and Train 7 is connected up to that switch box. And I also see 2 cameras have come up to it. So what I want to see right now is I don't know which one's mine. I mean, we really should have 4 systems connected up here, and I'm only seeing 2. So I have no idea what these are. So what I want to do is I want to go underneath System, add Sensor Device to Network, and it's going to go out there and it's going to first tell me, hey, no devices were found. So basically it's telling me no DHCP or no units with the wrong subnet was found here. Okay. But now what I want to see is I want to see the ones that are there. How do I do that? I got to right click and say show all devices. That it will do that. Now what I can do is I can take a look to see which one's mine. And this one right here happens to be mine. That one happens to be mine, so no one grabbed that one. I just looked at it here and it said F246. And so when I look at my MAC ID, F246, beautiful, that's mine. So I'm going to go in and I'm going to call this Bonnie and say apply. It says it's changed your devices. Yep, that's fine. Say OK. And so now if I go over here and I double click on Bonnie, it says train 6 is on it, so I'm going to bump you. And so what I see right here, once again, I'm back into easy builder mode. And so now I would just have to say view spreadsheet to get back into spreadsheet mode. Now there's a couple things that I want to point out here because this was left on by whoever had it last. You can notice right here it's telling me that I'm online. So I'm going to need to turn it offline, okay, so that I can actually get access to this. So I'm going to go choose this right here, and that turns it offline. Ta-da! Now I'm offline with it. Notice up here it's saying it's Bonnie, 7402. Now notice this I/O not responding. If I did a reset to factory defaults, that would take care of that. Okay, right now it's basically saying the I/O module that it was previously connected to, it no longer sees. And so now what I can also do right here is I can just get a new image or a new job. So I can either go underneath File, New Job, or just hit the little New Job icon, and it cleans things up. Now notice my image. I'm not worried about my image behind it right now. I don't care what's behind it right now, and I have no idea what it is, in fact. Once again, I'm not worried about the image. All I'm worried about is that I have a fresh, new spreadsheet and that I'm connected to my camera. That's where I want you to be at the end of this section.